Hi, this is Chapter 9, Inspection and Gauge Design. We're going to talk about things like tolerance. Okay, so tolerance on a part. That is the total amount by which a dimension may vary from a specified size. The designer specifies the ideal condition, which is a nominal dimension, and then states what's the allowable degree of error. So, tolerance may be specified indirectly in the bill of material. So if you're a designer and you're called for a purchase part, like for example a headless press fit bushing type P per ANSI, it is assumed that the catalog tolerances are acceptable and you don't really have to create a drawing and assign tolerances for standard parts. Okay, so tolerances must be compatible with the part function and the manufacturing capabilities. That kind of goes without saying because the part has to work in its assembly properly, and if your manufacturing production capabilities are not capable of making the part, then you got a problem. And then tolerance impacts cost. Really, as the tolerances become tighter, the cost of meeting them tolerances rapidly increases. So let's talk about coordinate tolerances, and this is number 1 on your objective sheet. Typically, the way things were done was a part was defined with a coordinate tolerance. That is a nominal dimension plus or minus some other dimension. And really what that does, it gives you a square tolerance zone, and that's what's illustrated right here. Where the cross hatches is, that's the perfect position of the hole or whatever the feature is. And then once you apply the coordinate tolerances, then that hole is permitted to be located anywhere within that square. Now, when we talked about geometric tolerances, we talked about something different. It was called a positional tolerance. And in most cases with geometric dimensioning and tolerancing, the positional tolerance zone was round. And this is a chart that talks about what the difference is, or how to convert from a equally bilateral tolerance zone, which is the coordinate tolerance zone, and a positional tolerance zone. Okay, so the next one was item number 3 on your learning objectives. These were the 4 classes of gauge maker's tolerance. And essentially what happens here is the tolerances increase in classes. And we can see what the next slide is. Okay, so what we're talking about here is the XX is the most tightest tolerances of the classes. Okay, so between 10 thousandths up to 825 thousandths, the tolerance zone of an XX is 20 millionths, and then 40 millionths for an X, 70 millionths for a Y, and then 1/10 of a thousandth for Z. So these are your classes of gauge makers' tolerances. So, gauge tolerances. Okay, so we're going to talk about this in a little bit, but the working tolerance is the tolerance that's assigned to the part feature. Now, as a tool designer, you would design gauges to allow you to inspect parts. So working gauges are used by production workers to check if the part meets the working tolerance. So typically when you design a gauge to check a part, that gauge tolerance is generally 10% of the working tolerance. So if you had plus or minus 10 thousandths for a part feature and you wanted to build a gauge to inspect it, you would have plus or minus 1/1000th on that gauge. And here is allocation of gauge tolerances. This tells you how the tolerance of the gauge is distributed with relationship to the working tolerance of the part. I'm going to have a separate movie on that topic in a little bit. I think that'll be the 3rd one of this series. So there are 2 basic allocation of gauge tolerances. Bilateral, so essentially what you do is you center the gauge tolerance in the part tolerance, the nominal part tolerance. With unilateral, the entire gauge tolerance is contained within the working tolerance. And again, I'll have a separate movie that talks about that. And that ends this movie. I'm going to have another movie for the rest of the slides in this chapter, and then there'll be a third movie that talks about gauge tolerance allocation and how to apply gauge tolerances. Okay.